In Chapter 12, we'll look at the internal memory available on the microcontroller. In today's threat environment, security is a major issue. We'll look at the security features that this device incorporates. Finally, we'll look at the memory protection unit and see its operation in the lab. Flash memory on this device is 1 megabyte in length starting at 0 and is organized into 8 kilobyte sectors. This memory allows 100,000 program or erase cycles with 20 years of data retention. It's organized into 4 banks of 16K by 128 bits, which are two-way interleaved for speed and reliability. Instructions are fetched through a 256-bit prefetch buffer to increase speed. Writes pass through a 32-word write buffer to reduce CPU overhead. Writing to the memory and executing from the memory can incorporate programmable protection. TivaWare provides you with a simple programming interface. The on-chip ROM starts at address 1,000,000 and contains the bootloader, the initial vector table, the TivaWare peripheral driver library, cryptography tables, and CRC error detection functionality. There are no provisions for adding customer code to the ROM at this time. EEPROM memory is 6K in length starting at 0x400A-F000. It's accessible as 1,536 32-bit words, which is broken up into 96 blocks of 16 words. Each block has access protection built in using 32 to 96-bit codes. This protection is also available at the module level. The memory has an endurance of 500,000 writes with built-in wear leveling. When writing to EEPROM from code, write completion can be assured either through polling or with interrupts. Random read-write accesses to EEPROM requires 4 cycles per word. Sequential writes require the same amount for the first access and then single cycle for each one afterwards. SRAM memory is 256 kilobytes starting at 20 million and operates at 120 megahertz. That physical memory is bit-banded into address 22 million. SRAM can hold code or data. You can execute code out of SRAM if you choose to do so. SRAM is physically implemented using 4-way 32-bit wide interleaved banks to increase speed between accesses. Tiva C-series devices utilize bit banding to reduce the number of read, modify, write operations done in your code. SRAM and Peripheral space use an address alias to access individual bits in a single atomic operation. Physical SRAM memory starts at a base address of 20 million. The bit-banded alias of that memory SRAM starts at base address 22 million. Peripheral space starts at a base address of 40 million. Bit-banded peripheral space starts at a base address of 42 million. To calculate the bit-banded alias, use the formula here. The code we'll be using in the lab does this at runtime. The memory protection unit defines 8 separate memory regions plus a background region that's accessible only from privileged mode. Regions 256 bytes or larger in size get divided into 8 equal-sized subregions. MPU configuration can be relatively simple or very complex depending on your goal. You can configure different attributes for each region and subregion. For example, allow code execution, allow data, allow writes, etc. Accessing a region in a prohibited way will cause an immediate memory management fault. Many customers find it important to secure their programming efforts from unwanted snooping or duplication. Each 2K flash memory block can be configured using the FMPPE and FMPRE register bits to execute only, read only, or the default unsecure state. To further protect the device, the debugger ports can be disabled using the DBG bits. Bear in mind that a mechanism should be provided to re-enable these ports, since the device will be inaccessible once the ports are disabled. In case you require access to the device after the ports have been disabled, the user's guide provides an extensive set of steps to accomplish this. Once done, the device's flash memory, including the MAC address, will be mass erased. The Tamper module provides the user with mechanisms to detect, respond to, and log physical tampering events to the system. The module is designed to be low power and operates either from the battery backup or from the microcontroller's voltage supply. This module is a sub-module of the Hibernate module. A state transition on any of up to 4 tamper-designated I/O pins triggers a tamper event. Failure of the hibernation crystal can also trigger a tamper event and will switch the clock source to the low-frequency internal oscillator to assure that the module continues to operate. There are several possible responses to tamper events, like the module can set the tamper status bits, it can generate a non-maskable interrupt, it can clear some or all of the battery-backed memory, it can wake from hibernate, it can log up to 4 events. Cryptographic accelerators are implemented in hardware in Tiva TM4C129X devices. These accelerators include a CRC engine supporting both 32 and 16-bit calculations, a Symmetric encryption engine supporting both AES or DES standard in hardware, and a hash-based authentication capability using SHA and MD5 algorithms. The Advanced Encryption Standard, AES, security modules provide hardware-accelerated data encryption and decryption operations based on a binary key. The AES is a symmetric cipher module that supports a 128-bit, 192-bit, or 256-bit key in hardware for both encryption and decryption. The purpose of the DES algorithm is to encrypt, encipher, or decrypt, decipher, binary coded information. This is a somewhat older group of algorithms and a bit less popular than AES. In Lab 12, we'll use TivaWare API calls to write code that writes to flash and reads and writes from EEPROM. We'll experiment with the memory protection unit and bit banding in SRAM.